Let's say that you're bored, so you open your phone to TikTok. Lately, you've been watching lots of dog videos, so TikTok recommends you more dog videos. But how does TikTok know how to do this? TikTok, as well as other popular apps, uses a machine learning algorithm based on the K nearest neighbors algorithm, or KNN for short, that suggests topics based on similarity. Before we dive in, let's get to the basics. So KNN is a machine learning algorithm, but what exactly is machine learning? Let's use a factory example. Machine learning is a method where we feed input data or material into a model, the factory. Then it outputs a prediction, a product. Simple, right? But how does the model know what to do with this input data? Most models first need to learn a rule from the data, but this process can be quite complex and lengthy. Some can come with extra restrictions. Think of this as extra costs to create the final product. However, KNN is different in the sense that it does not need to learn some fancy rule beforehand. It instead waits for a new data point to show up, then follows a simple set of instructions. KNN works on both regression, where predictions are numerical, and classification, where predictions are classes. In this video, I will be focusing on classification for simplicity. KNN works on the principle that similar data points are often grouped closer together. Think of this as friend groups. You are more likely to be friends with those who share the same interests. Let's take a look at this through an example in 2D. Suppose we have two types of aliens, A and B, and we have some information on 20 of them. We plot every point in our dataset as so. Let's introduce a new alien, alien C, who we do not know which class it belongs to. We plot C onto our graph as so. Let's see KNN in action. First, take a look at the closest points around C. Call these points neighbors. Next, let's decide on how many neighbors to pick. Call this number K. Examine the classes of these neighbors to perform a majority vote on C's class. Whichever class appears the most often will be C's predicted class. For example, if we have 5 purple points and 3 green points, the majority is purple. This is also why we pick an odd number for K, to avoid potential ties. Let's pick K equals 5, so we will be examining the 5 closest neighbors to C. Here we've gotten 3 points from A and 2 points from B. The majority is A, so we will predict that alien C comes from class A. As we can see, similar points belong to the same class. While there's still the chance of making an error in classifying C based on the neighbors considered, in general, the points are correctly classified. KNN, however, comes with its downsides. One main downside is how long it takes to predict not just one, but multiple new data points. Let's say we're now trying to predict a set of 10,000 different aliens. The process of individually selecting the K nearest neighbors, then performing a majority vote, starts to increase the time it takes to predict every alien's class. KNN appears in many different applications, including Netflix user recommendations, Google search, image classification, and more. KNN shows us that a simple idea that similar ideas are grouped together can help us tackle a complicated problem, predicting the class or value of a data point. There's many ongoing research in this field, such as reducing computation time and higher accuracy. Now we can understand how TikTok and other social medias can quickly recommend you new dog videos easily.